We now get to begin section 2.3, and we just have some general information questions right off the bat. Question number 1 asks, what is the domain of the cosine function? In other words, what values can we actually plug into the cosine function? The nice thing about that is there's absolutely no restrictions, and so the domain of the cosine function is all real numbers. Number 2 asks, what is the range of the tangent function? Well, the tangent function can, if you look at the fact that it's x over, or correction, it's x over y, then, I'm sorry, y over x, then we can see that any value is possible. 0, positive, negative, very high positives, very low negatives, and so the range would also be all real numbers. The next group of problems say use the fact that the trigonometric functions are periodic to find the exact value of the expression, and we are not allowed to use a calculator. And so we begin with the sine of 855 degrees. And what it means to be that it is periodic means we need to actually get it into a manageable angle. And so if we look at 855 degrees, that would be, one trip around would be 360. The second trip would make a total of 720, and so that leaves only 135 left, which puts us over here. So this becomes the angle 135 degrees that we needed to have left. Now, from last section, we realized that we need to find the reference angle. If this is 135 degrees, this angle right here, then that would leave 45 degrees of an angle here. Now, in the second quadrant, sine is positive, so we have a positive some number, and in particular the sine of 45 degrees is square root of 2 over 2. Number 4 asks for the cosecant of 540 degrees. Well, once again, the first thing we have to do is to determine what the reference angle is going to be. So going all the way around, we get 360 degrees. Now if we go another time around, we get 720, so we've already gone too far. So from 360, we have to go 180 degrees further, which is this angle right here. It's the negative x-axis over here. Now, first thing we have to do is realize that cosecant is the reciprocal of sine. And so what we look at is, okay, what is the sine of this angle, or this terminal side right here? And if you do the calculations, this is a reference angle of 0. Well, the sine of 0 is 0. Unfortunately, the reciprocal of 0 is 1 over 0, which means it is undefined. Question number 5, what is the tangent of 13 pi over 4? And what we can do is come back up here and use this particular diagram. 13 pi over 4. Well, going all the way around is 8 pi over 4, leaving an additional 5 pi over 4. Well, 5 pi over 4 takes us to the third quadrant. The reference angle would be right here, and this reference angle, if we go all the way around, that's 8 pi over 4, 12 pi over 4, which would leave pi over 4. So, all students take tangent is positive in this quadrant, and so we know our answer will be positive, and the tangent of pi over 4 is 1. The next group of problems deals with just some word problems, very short word problems. If the sine of theta is 0.8, then we are asked to find what would the value of sine of theta plus the sine of theta plus 2 pi plus the sine of theta plus 4 pi. Well, hopefully it doesn't take too much to realize that if we have a sign that happens to be positive, then that means it's either going to be in quadrant 1 or quadrant 2. Now if it's in quadrant 1 and we add 2 pi to that, it's still going to end up in the exact same place. And if we add 4 pi to that, it will end up in this exact same location. The terminal side is the same in each case. Like, the same argument can be used for the second quadrant. So we know that the sine of theta is 0.8. The sine of theta plus 2 pi, it ends up in exactly the same place, so that's going to be 0.8. As will when we add 4 pi. And so we get 0.8 plus 0.8 plus 0.8, which is 2.4. Number 7, f of theta is the cosine of theta, and we know that f of a is negative 1/12. We want to find the value of f of a plus f of a minus 2 pi plus f of a plus 4 pi. And since we're talking cosine, because that's what f of x is, or f of theta is cosine of theta, then we realize that anytime we add 2 pi or any multiple of 2 pi, and any time that we subtract a multiple of 2 pi, we will end up with the exact same value. So since f of a equals negative 1/12, we can do that. Plus, okay, even though we're subtracting, we're going to end up in the exact same location. So plus of negative 1/12 plus negative 1/12. And negative 1/12 plus negative 1/12 plus negative 1/12 is negative 3/12, or negative 1/4. The next group of problems just ask which quadrant does the angle lie in. Number 8 says the tangent of theta is positive. Okay, tangent of theta is positive only in quadrants 1 and 3. But then it turns around and says that the sine of theta is negative, or the sine of theta is less than 0. And so that means it would have to be quadrant number 3. Number 9 is the same type of problem. It says the cosecant of theta is greater than 0. Or in other words, the cosecant of theta is positive. We have to think. The reciprocal of cosecant is sine. So sine is positive in quadrants 1 and 2. But then it turns around and says the secant of theta is greater than 0, or the secant of theta is positive. Since the secant is positive, that means the cosine is positive. And between these two quadrants, only quadrant 1 is where cosine is positive. Example number 10, the cotangent of theta is greater than 0. Cotangent of theta is positive, which means tangent needs to be positive. Tangent is positive only in quadrants 1 and 3. Then it says that the sine is less than 0. The sine of theta is less than 0, which means sine is negative, and therefore quadrant 3 is the quadrant that it is in. Now, example number 11, we are told that the sine of theta is equal to the square root of 7 over 4, and the cosine of theta is 3/4. We need to find what is the tangent of theta. Now, a couple things that have to go on here. The first thing we really want to do is to determine which quadrant are we talking about. Well, here we know the sine is positive, cosine is positive. The only quadrant where sine and cosine are both positive is in quadrant 1. So we know that in quadrant 1 everything is positive, so the tangent of theta will be positive. But then what we do need to do is we need to draw a triangle here. And it needs to be a right triangle, and I'm going to put my angle theta here just as a general rule. Well, if sine of theta is square root of 7 over 4, here we're going to use the fact that the sine is actually the opposite side of the angle over the hypotenuse. The opposite side to this angle right here is right here, and so this would be the square root of 7. The hypotenuse is this number right here, 4. Now it doesn't take too much, or we can do a very quick calculation using the Pythagorean theorem. This would become 4 squared, or 16, equals square root of 7 squared, which is 7, plus b squared. And then subtracting 7 we get 9, and taking the square root of both sides, b would equal 3. And so this is what that other triangle becomes. And if we look, the cosine of this angle right here, the cosine is the adjacent over the hypotenuse, the adjacent side, so that's 3 over 4, which does comply with what we've got. Now finally, to answer the question, we've already known that the tangent of theta is positive, but the tangent is the opposite side over the adjacent, so that would be the square root of 7 over the adjacent leg, which is 3. Square root of 7 over 3 is the final answer.